Hey there, this is lesson 17, the flame test, in particular how it works. If I can do this in under 5 minutes, I get a piece of candy. So let's hope for that. Alright, so first off, why we care about this. The big reason is fireworks, because they're cool. So the way you get blue fireworks is by burning a certain chemical red, a certain chemical green, another chemical. And if we could ever figure out how to get flames this nice looking, it would be a lot easier for us to do the lab. But the other helpful thing about the flame tests is evidence for compounds. So, if I have some mystery substance, which you will have later on in the year, you'll get a little vial of stuff, you have to tell me what's in it. One helpful tool is a flame test, because if you burn it and it's red, it will be lithium something or other. Or we did strontium. Orange, or orangey red, it'll be calcium. Yellow-orange, sodium. So there you go, Kaylee. That's the yellow you kept seeing. Basically, our results match this pretty well. Most people said kind of green rather than greenish blue on copper. We have potassium, which was pink or lilac. And the thing with these is it's the metal that makes the difference, not the non-metal. So if you look, all of these have nitrate, 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 nitrate. So if you burn blank NO3, you don't know what color that's going to be. You cannot figure it out. But if you burn Li blank, you know it's going to be red. So whatever's connected to the lithium, it's going to be red. So you can at least identify the metal based on a flame test. So, how it works. Not that. Alright. You have electrons. And they're all over inside the atom on different shells, so this isn't the full shell. But what happens when you heat stuff up, Josh Hinkle? He's doing the particle dance now. So, things get excited, whatever you are. If you're an atom, if you're a person, you get hot, you're going to get excited, move around more. So these electrons get excited and move around a whole bunch. And so when they get excited, they are able to jump out to outer layers. Let's move to one. So this guy gets excited. No, not that one either. This guy gets excited and he jumps out to an outer level. So he went up 3 levels, or I guess 4 levels, because of absorbing that energy. So when you get higher energy, you get to move farther out. You have low energy, you're at the bottom. So that's what these rows are, these shells, they are energy levels. But, just like when you get all hopped up on sugar and you're all hyper and crazy, eventually you have to come back down. So, you fall back. And as you fall back, your energy gets lowered. So, if you cannot create or destroy energy, where does the energy go? The energy to move the electron from here out was because of the heat. So you turn heat into crazy particle dance. But when you slow down your particle, what happens is the energy gets sent out as light. There are rays of light sent out because of the heat that got turned into moving around, that got turned into light. And so that is what produces the different colors. Because some things go up 1 and then down 1. Some things go up 2 and then down 2. Some things go up 6 and then down 6. So the number of energy levels is how high your energy is. So if we're looking at our different colors, we have like strontium, that was red. We have potassium, that was purple. And so the way to remember the colors is more levels means that you have more energy, and that means that you are more violet. So you can remember that. I'm not going to get my candy. Man, so disappointed. You can remember that by the idea of UV light. So ultraviolet, just on the other end of the visible, so there's the violet, there's also energy that we can't see that's like we get from the sun. If you compare that to infrared light, you are shooting off infrared light. There's radiation. So if you're doing like those night vision goggle things, or something of that on TV, you see the little blurry red splotch in the middle because you are giving off this infrared heat. So to remember, more energy, more levels means more violet. Think of the sun compared to you or whatever's sitting around the house. It's all giving off infrared energy. So potassium, that means for potassium, the electrons went out really far and then fell all the way back down. So they shot out several levels of energy. So that means their wavelength is closer to the high energy. For something like strontium, it may have only gone out 1 or 2 levels and then come back down. So that's shooting out the visible light. So more levels, more energy, more violet. You could also remember think of the idea of it being energetic and high-powered. You could almost call it violent if you put an N in there. Whatever helps you remember. I don't really care. Other cool things with this is a thing called, let's go back there. There we go. A spectroscope. And so you don't see it all the time, but everything's kind of giving off these different colors. So this is a thing called a spectroscope, and the end of it is a diffraction gradient. So it's kind of like a prism that splits up the light that you receive into the different colors. And so if you look at like 2 different kinds of light bulbs, one light bulb will be sending out these colors. Now your brain puts these together in one and calls it white light. But if you compare that to a sodium vapor lamp, that's like the ones that are in parking lots at night, so they always they glow yellow. I almost said red, Kaylee and Emily. It's going to look yellow to us because there aren't other colors to blend in and make it white. So if we look at the colors of other chemicals, like there's our lithium, which if you find the major lines, that's what the color ends up being. So the major lines on that would be like the yellow, or it's got a lot of red. Strontium looked red. It's got a lot of other lines, but one of the brightest is that red there. Calcium, a lot in the red. If we look at sodium, because sodium burnt orange for us, so it's really highly in the yellow there. And so that's what the spectroscope would make it look like. And so pretty much any chemical burning is going to give off all these colors. Our brain puts it together to make white, but if we looked at a flame, that's going to be whatever the strongest single band is, which for sodium would be the yellow. So again, how it works, electrons just increase energy, then shoot out light. If they shoot out high energy, it's more purple. If they shoot out low energy, it's red. The end. I'm probably going to eat the candy anyway. Just not going to lie. Okay, take care.